the future of discoveries. NASA's Chandra X-ray Observatory has been exploring the high-energy universe since 1999, detecting phenomena such as star explosions, black holes, and massive galaxy clusters. Along with observatories like the Hubble Space Telescope and the James Webb Space Telescope, we are able to get a more complete picture of the cosmos across different types of light, from visible to infrared and X-ray. These telescopes generate vast amounts of data, more than scientists could analyze manually. This is where artificial intelligence, AI, comes into play. AI tools help astronomers quickly classify objects, detect unusual patterns, and make new discoveries hidden in enormous datasets. By training AI, scientists can speed up their research, uncover surprises, and share more of the universe's secrets with the world. Artificial intelligence algorithms use similar processes to identify and classify celestial objects from vast amounts of observational data. Imagine you are a space detective, and the universe has sent you a mystery file full of unknown objects. Some of them are stars, some are galaxies, but they all look pretty similar from here, on Earth. Could you figure out which is which? And could you teach a computer to do it for you? Why do we care? We study stars and galaxies because they are the building blocks of the universe. Stars form almost all the elements that make up planets and life itself our own, while galaxies show us how the universe is organized on the largest scales. By understanding how stars form, evolve, and die, and how galaxies grow and interact, we can trace the history of the cosmos and our place within it. Modern telescopes collect impressive amounts of data about stars and galaxies, far more than humans can explore on their own. AI tools allow us to sift through this flood of information, detect patterns we might miss, and make new discoveries faster. By combining human insight with the speed of AI, we can uncover the hidden stories of the cosmos and deepen our connection to the universe in which we all live. The science of stars and galaxies. Our Milky Way galaxy contains several hundred billion stars of various ages, sizes, and masses. A star is formed when a dense cloud of gas is compressed by gravity until nuclear reactions begin deep inside the cloud, providing enough energy to stop the collapse. Many factors affect a star's life and final form, but the most important is its initial mass. A star with a mass similar to the Sun's will become a white dwarf. A more massive star might explode as a supernova, leaving behind a neutron star. Galaxies are gravitationally bound systems of stars, gas, dust, and dark matter. A typical large spiral galaxy, such as our home galaxy, the Milky Way, consists of hundreds of billions of stars, enough gas and dust to form billions more stars, and at least 10 times more dark matter than all the stars, gas and dust combined. This type of galaxy is defined by its characteristic spiral shape with visible arms of dust and gas rotating around the center. An elliptical galaxy has stars distributed in an elliptical shape, from elongated to nearly round. The light is smooth, and the apparent brightness decreases as you move away from the center. An irregular galaxy is an odd-shaped galaxy, often rich in interstellar matter, but not belonging to any of the main spiral or elliptical galaxy classes. The science of stars and galaxies is, at its heart, the story of everything that has ever existed and everything that ever will. To study these objects is to study the life cycle of matter itself, from the smallest dust particles floating in interstellar space to the grand luminous structures that stretch across millions of light years. Every star begins humbly, as a cold and silent cloud of hydrogen and helium drifting through the dark. But over time, gravity, the quiet architect of the cosmos, pulls this gas together. Denser regions form knots, knots ignite into spheres, and eventually, under enough pressure and heat, a miracle occurs. Nuclear fusion lights the first spark of a star's life. From that moment on, a star becomes a cosmic engine. It burns, it shines, and it creates the heavy elements that one day will form planets, oceans, mountains, and even living beings capable of asking where they came from. Stars do not exist alone. They gather in clusters and swirl inside galaxies, vast cosmic metropolises filled with billions or trillions of suns. Some galaxies form elegant spirals with long, graceful arms. Others are massive, featureless ellipses, and some appear chaotic, shaped by ancient collisions or still undergoing cosmic turmoil. These shapes are not random. They are the fingerprints of the universe's history. Every twist, every distortion, every glowing arc marks a moment when galaxies encountered one another, merged, or were torn apart by tides of gravity. To understand galaxies is to understand the architecture of the universe itself. Galaxies grow, interact, cannibalize their neighbors, and seed new stars in bursts of creation. They orbit within massive halos of dark matter, an invisible component that outweighs normal matter 5 to 1. Without dark matter, galaxies would fly apart. With it, they form intricate cosmic webs, spanning hundreds of millions of light years. This structure is the skeleton of the universe. But the map of the cosmos is vast and complex, far too large for humans to study manually. Modern telescopes like Hubble, Webb, Gaia, Chandra, and many others collect unimaginable quantities of information, more data than an entire generation of astronomers could analyze in a lifetime. And this is where artificial intelligence becomes a revolutionary force. AI doesn't just accelerate research, it changes what is possible. Machine learning systems can classify millions of galaxies in minutes, identify faint objects buried in cosmic noise, and detect exoplanets by analyzing tiny dips in starlight that humans might overlook. Deep neural networks learn to recognize gravitational lensing, the warping of light caused by massive objects, helping to map dark matter with unprecedented detail. Other models analyze the flickering of distant stars to uncover patterns that indicate stellar storms, pulsations, or hidden companions. But AI goes beyond observation. It can simulate entire universes. With powerful algorithms, astronomers recreate cosmic evolution across billions of years, watching how matter clumps together, how galaxies collide and merge, how stars are born and die. These simulations allow us to test our theories against reality and predict what the universe might look like in the distant future. In many ways, artificial intelligence has become a new kind of telescope, not one that collects light, but one that reveals structure within data. It uncovers phenomena that astronomers did not expect, identifies rare objects that challenge our understanding, and often asks new questions before we even know to ask them ourselves. As our instruments grow more powerful and our datasets expand into the realm of trillions of measurements, the partnership between human curiosity and machine intelligence will deepen. Together, they will search for the first stars that formed after the Big Bang, trace the growth of cosmic filaments, explore the environments around supermassive black holes, and perhaps even detect signatures of life on distant worlds. The universe is vast, ancient, and full of mysteries, but it is not unknowable. With AI as our companion, the cosmos becomes a little less silent. Patterns emerge. Hidden structures reveal themselves. The story of creation becomes clearer, one discovery at a time. And as we continue to explore, we are reminded of something profound. That the atoms in our bodies were forged in the hearts of stars, that galaxies shape our destiny on cosmic scales, and that by studying the universe, we are ultimately studying ourselves. Yet, even with all the tools at our disposal, the universe remains a place of infinite wonder and hidden surprises. Every time we point a telescope to the night sky, we are confronted with phenomena that defy our expectations, stars that pulsate in strange rhythms, galaxies colliding in slow-motion cosmic dances, and mysterious bursts of energy that erupt seemingly from nowhere. These are the puzzles that have inspired generations of astronomers, and today, artificial intelligence gives us the ability to tackle them on a scale never before possible. Consider the life cycle of stars. While we understand the broad stages, formation, main sequence, and eventual death, the details are often elusive. Supernovae can explode in unexpected ways, leaving behind neutron stars or black holes that warp the space around them. Binary star systems, where two stars orbit one another, behave in complex gravitational dances that can produce ripples in space-time called gravitational waves. AI helps us track these interactions, identifying subtle patterns and anomalies in the light we receive from millions of stars. It can even alert astronomers to rare or transient events, like a supernova that might otherwise go unnoticed in the vast expanse of the sky. Galaxies, too, hold secrets that AI is beginning to unveil. Massive surveys of millions of galaxies reveal not only their shapes and compositions, but also their histories, tales of ancient mergers, tidal interactions, and bursts of star formation triggered by cosmic collisions. With machine learning, we can identify faint structures, such as tidal streams and stellar halos, that hint at events billions of years in the past. These discoveries allow us to reconstruct the evolutionary story of the cosmos, piece by piece. Beyond just cataloging objects, AI can also help us understand the very laws of physics that govern the universe. By comparing observations with simulations, researchers can test theories about dark matter, dark energy, and the expansion of the universe. Models trained on real astronomical data can suggest new hypotheses, highlight inconsistencies, or predict what might be discovered next. In this sense, AI is not merely a tool, it is a collaborator in the scientific process, expanding the reach of human imagination into realms that were previously inaccessible. Moreover, the application of AI in astronomy is fostering a new kind of creativity. Visualizations produced from machine learning algorithms allow us to see the universe in ways that are both scientifically accurate and breathtakingly beautiful. From intricate maps of cosmic filaments to simulations of star-forming regions glowing in ultraviolet light, AI helps transform raw data into narratives that can inspire scientists and the public alike. As our technological capabilities continue to grow, the possibilities seem limitless. Future missions will generate volumes of data that are orders of magnitude larger than anything we have seen before. Telescopes like the James Webb Space Telescope, the European Extremely Large Telescope, and next-generation radio arrays will probe deeper into the cosmos, capturing light from the earliest stars and galaxies. Without artificial intelligence to process and interpret this information, much of it will remain hidden. But with AI, we can begin to piece together a coherent and ever more detailed picture of the universe's past, present, and future. Ultimately, the study of stars and galaxies is a story of connection. Every photon of light, every particle of matter, every gravitational ripple links us to the broader cosmos. By combining human curiosity, technological ingenuity, and artificial intelligence, we are gradually decoding the grand narrative of existence. We are uncovering the origins of the elements in our bodies, the formation of the solar system, and the intricate web of galaxies that defines the large-scale structure of the universe. In doing so, we gain not only knowledge but also a profound sense of our place in the cosmic order, and a humbling awareness that, despite our smallness, we are capable of understanding the vastness around us. The journey has only just begun. Each discovery opens new questions, each observation reveals new mysteries, and each insight reminds us that the universe is far more wondrous than we can imagine. With artificial intelligence as our guide, the stars, galaxies, and the deepest secrets of the cosmos are no longer beyond reach. They are waiting for us to explore, to understand, and to marvel at.